All right, you should be on page 9 in Unit 4. This is Lesson 1. And we're going to look at what's called a hanger diagram here. Hanger diagram. And the basic premise of hanger diagrams is that one side of the diagram is equal to the other. Kind of like an equation. And that's the whole point, is it's a visual representation of an equation. So we want to find out if a triangle weighs 1 gram, how much does a square weigh? So we want to find out how much these squares weigh if we know that the triangle is 1 gram. So the first step you want to do whenever you have hanger diagrams is to label them. So if you're given information that triangles weigh 1 gram, label it 1, 1, 1, 1, 1, 1, 1, and 1. Great. So you have now 2 on the left-hand side plus 3 squares is equal to 5 on the right-hand side plus 1 square. So let's write that as an equation. 2 squares, or 2 triangles. So just the value of 2. We don't need to write a triangle because we just know the value is 2. Plus 3 squares, I'll just write 3s, equals 1, 2, 3, 4, 5 plus 1 square plus 1s. So we've written our equation. Now we can solve. But the act of solving means that we just take away equally from both sides, right? Equal sign highway. Only instead of a highway, you can think of that there's like this imaginary dotted line in between. And whatever you take away from one side of this imaginary line, you can take away from the other. So can we take away 1 triangle and 1 triangle? Yes, we can. Can we take away 2 triangles? Yes, we can. Can we take away 3 triangles from each side? No. So in our equal sign highway, we're just going to take away 2 because we took away 2. And on this side, we're going to take away 2 equals 2 minus 2. So we take away, and that leaves us with 0 on the left, 0 triangles on the left-hand side equals 3 squares. And we take away 2 triangles, we're left with 3 right here, which makes sense. Okay, so equals 3. But then we also have squares on each side. So let's take away 1 square. We can take away 1 square, right? Cool. Can we take away 2 squares? No, there's only one. There's a second square on the left side, but there's no second square on the right-hand side. So we can take away 1 square equally to both sides. Now we take away that 1 square, we're left with 0 squares on the right-hand side. But we take away 1 square from the right-hand side, we're left with just 2 squares. So 2s equals 3. If 2 squares are 3, then 1 square, because we want to find if 1 triangle is a gram, how much does a square weigh? We want to find out. 1 square is, well, 1.5. Or 3 halves. Let's move to the next question. Find the weight of square. So we want to find what the square is in hanger A, and the weight of a pentagon in hanger B. So the pentagon, these yellow figures with 5 sides. And I think it's going to be easy for us to do after we write the equation for each hanger. All right, so let's do that. So for the A side, for the A diagram, we have 1 triangle, so T for its triangle, plus 3 circles, 1, 2, and 3. It doesn't matter the order, you're adding them anyways. Plus 3 circles, plus a square, equals 1, 2, 3, 4, 5 squares, plus a circle. Woo, okay. So that's the equation to represent this hanger. Cool. And then for hanger B, We have 2 circles on the left-hand side, so 1, 2, 2C for circles, plus 2 P's for pentagons, equals 2 P's on the right-hand side, 1, 2, plus 2 triangles, T, 2T, plus a circle. So that would be writing the equation for the hanger right here. Now we can notice some things here. We notice that we're told at the top of the page T equals 3 and C equals 6. So let's do all of that plugging in. Let's do that substitution. Okay. So T is 3, so 3 plus 3 times 6 plus S equals 5 times S plus 6. Okay? And then on the right-hand side, we know that C is still 6, so 2 times 6 plus 2P equals 2P plus 2 times 3 plus 6. Very good. Let's do some simplifying now. 3 times 6 is 18. 3 plus 18 is 21. So 21 plus S equals 5 times S plus 6. And then on the right-hand side, 2 times 6 is 12 plus 2P equals 2P plus, well, 2 times 3 is 6 plus 6, 12. Very good. Now we can do some simplifying for each of these. Let's equal sign highway these bad boys. Okay. Subtract 6 from both sides. Subtract 6. And then subtract an S. Subtract an S. And remember, these are equal. So minus 6 minus X. Minus 6 minus S minus 6. They're the same thing. So let's do some canceling. That becomes 0. This becomes 0. And we're left with 15 equals 5S minus 1S is 4 S's. So 15 equals 4S. So that means 1S is 15 over 4. So S equals 15 divided by 4. And then P on the right-hand side. Let's put our equal sign highway. Subtract 12 equally to both sides, right? Subtract 12. This goes to 0. And this goes to 0. We're left with 2P equals 2P. Well, let's divide each side by 2. Divide by 2. Divide by 2. Cancel, 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 cancel. You're left with P equals P. That means anything is true. If you chose 1, 1 is equal to 1. If you chose negative a million, negative a million is equal to negative a million. So P could be anything. Any number. What is the weight of a square on this hanger if a triangle weighs 3 grams? Well, just like before, we want to find out what the weight of a square is. So S equals something when the triangle is 3. So T equals 3. So the triangle, we're going to label all of them 3s. 3 and 3 and 3 and 3 and 3. Then we'll write the equation. So 3, 6, 9. So 9 plus, well, 2 squares, 2s, equals, well, 3 plus 3 is 6. 6 plus 1 square. We'll equal sign highway. And then we will subtract 1s from each side. So minus 1s, minus 1s. Okay, so that goes to 0. And subtract 9 from both sides, minus 9. And so the 9 minus 9 goes to 0. And we're left with 2s minus 1s is 1s. 6 minus 9 is negative 3. So the s, or the square, is negative 3. So like anti-gravity, I guess. That's pretty cool. And the last question for Today's modeling. Figures A, B, C, and D show the result of simplifying the hanger in figure A by removing equal weights from each side. Here are some equations. Each equation represents one of the hangers. Well, I think the easiest is going to be D. So let's see which equation looks the simplest. Yes, this one. 2y equals x. Well, there's two triangles equals one square. So a triangle must be y. Okay, so a triangle equals y. And that means x must be a square, right? Square equals x. Cool. So that means this is letter D is 2y equals x. Done. Next, we look for 3y's plus an x equals 1y plus 2x's. And that's this one right here. Okay. So that's going to be x plus 3y equals 2x plus y. B, well, this looks like, well, a group of 3y's plus x and 3y's plus x with 4x's and 2y's. So 4x's and 2y's and two groups of x plus 3y's right here. Okay, so that's going to be letter B. And then letter A, by process of elimination, is going to be right here, but that makes sense as well because now we have a new variable and we have a new figure. So the circle is equal to our z, okay, because that's going to be our new variable. So A is this long one right here, B right here, C is written here, and D is there.